Okay, let's get started. Actually, I want to apologize. I've almost lost my voice with all the screaming last night, so please forgive me. Good morning, everyone. My name is Anil Kumar. I'm the product manager of AWS CloudFormation. This session is What's New with AWS CloudFormation, DEV321 repeat session. The first one was on Tuesday, really early morning, 8:30 at Aria. Really enjoyed my session there. This is my third year at reInvent representing AWS CloudFormation. Has been a tremendous journey so far for me. One of the best times of the year for any product manager, to meet customers, collect feedback, etc. For this session, I have two more folks with me. I would let them introduce themselves.
Go ahead.
Oh, go ahead.
I'm Manu. I'm a software engineer at Amazon.com, and I work on the information security team.
Thank you. And good morning. I'm Luis Colon, and I'm a senior developer advocate for CloudFormation, and I've been with the team for the last 2 years.
Thank you, folks. As you know, Luis has also lost his voice, so.
Good luck, buddy.
Yeah, thank you.
You'll be all right.
Yeah. All right. We are going to talk about some of the features that we have released in the past and some of the projects that we are doing, some of the open source projects. And the best way to think about those features and open source projects are the projects in terms of these three buckets. The first one is modernizing and extending AWS CloudFormation. In this one, we will talk about what we are doing with our AWS CloudFormation console. And I will also talk about resource support. That's our bread and butter, adding new support for new services and new properties in AWS CloudFormation. The second one is about managing enterprise complexity, collecting a lot of feedback from customers, enterprise customers operating CloudFormation at scale. They're running into challenges, and they provided feedback, and we have released some of the features to address those challenges. So I'm going to talk about some of the features in that bucket. And the last one is improving developer productivity in CloudFormation. A lot of feedback around this one. Folks are asking how we can further improve developer experience in CloudFormation, and we are kind of doubling down on this effort of improving developer productivity and experience in CloudFormation. So Luis is going to talk a little bit more about improving developer productivity, and he's going to share some of the projects that we are doing to improve the developer experience in CloudFormation. I believe there are a few folks in the room who are getting started with CloudFormation and wanting to learn more about CloudFormation. It's always good to take a step back and talk about what is CloudFormation. So kind of 101 for you. CloudFormation is an infrastructure as code service by AWS. It allows you to provision and operate infrastructure on AWS. A lot of customers have provided us good feedback and compliment that if something is not available in CloudFormation, an AWS service not available in CloudFormation, then it doesn't exist. It's a great compliment for us. At the same time, it's a great responsibility for us to respond on those comments. So my team is kind of fully aware of this, and we are iterating as fast as we can. And you will see acceleration a lot more from the CloudFormation side, both on the coverage front and from the feature side. And I want to share something more. Huge majority of the top 10,000 AWS customers, based on their spend on AWS, are actually using CloudFormation to operate their both production and non-production infrastructure on AWS. So going back to our three themes, the first one is about modernizing and extending AWS CloudFormation. So we are going to talk about the console experience, what we are doing with the console, CloudFormation console, and the resource type support. If you have noticed, a couple of weeks ago, if you will, we launched this redesigned AWS CloudFormation console. So the goal is actually to improve the stack creation and stack management experience using console. A lot of new customers, who are getting started on CloudFormation, actually they start with console, and we want to make sure that they have really good experience when they get started with CloudFormation console. So apart from improving the overall experience of creating and managing CloudFormation stacks, we want to make sure that we hit all the check marks from the accessibility standpoint. Want to make sure that the new console is responsive to different form factors. And we wanted to allow ourselves some real estate. In the new console, we have several features coming up, several features on the roadmap. And we want to make sure that we have enough real estate in the new console so that when we release those new features, it comes across as seamless and intuitive and easier to discover for you folks.
That's really cool.
Still early days here. We are getting a lot of good feedback as well as constructive feedback on our new console. Today it's opt-in, but we are going to sunset our old console eventually. So what you can do right now is try out the new console. If you have any feedback, there's a feedback link in the console. Please provide your feedback. And we have already gotten a lot of feedback from customers. And the feedback collected via this channel kind of directly flows to our product management team. And we help all the feedback collected here to triage and prioritize features for console and for other parts of CloudFormation. So please do check out the new console. We will be actually making this as the de facto console in the future. OK, let's talk about the resource type supports, our bread and butter. So today, we support over 300 resource types in CloudFormation. This year, till date, we have added almost 65 new resource type kind of spread across different 18 or 19 different AWS services, or over 18 different AWS services. Let me iterate this point once again. Our goal is to actually have day one support for all the new services and all the new features in CloudFormation. We are not there yet. We want to be there at some point. On the CloudFormation side, we are making a lot of investment from different angles to make sure that this happens in future. So I just wanted to reassure you folks that we know about this, and this is our priority number one. Talking about extending CloudFormation to support services, I just want to highlight custom resources. It's not a new feature, if you will. You can use custom resources, the feature in CloudFormation, to actually include resources that are not available in CloudFormation. It's a way to kind of bridge the gap. And not just bridge the gap, but using custom resources, you can bring in new abstractions, your own user-defined abstractions to CloudFormation. It's a way to extend CloudFormation in a nice way. Why I'm bringing this topic? Because in future, we are going to iterate on this feature to make it easier to create custom resources and also manage custom resources. So stay tuned on the custom resources one. I'm not sure how many of you have already noticed. We released a new resource type for Alexa skills, Amazon Alexa skills, Alexa : ask : skill. It's a native, I would say, is the first non-AWS resource type natively supported in CloudFormation. How many of you, just show of hand, how many of you already know about this resource type in CloudFormation? Nobody. Wow. Please do check out, if you are an Alexa developer, this might interest you. Before double-clicking on this resource type, I just want to call this out. If you have any feedback related to coverage gap, resource type support, please reach out to us proactively. You can reach out to your account managers. If you don't have account managers, please reach out to me. On Twitter, you can tweet me, DM me. You already know Jeff Barr and a couple of developer advocates on the CloudFormation side. Please reach out to them and provide your feedback. So Luis is responsible for this animation, so thank him. All right. So similar to serverless, if you see around the serverless, different serverless frameworks out there, most of them are actually based on CloudFormation. Like most of them are running CloudFormation behind the scenes. So what we did back then, like we brought infrastructure as code techniques to all the serverless developer serverless community. Similarly, what we are trying to do here is bring infrastructure as code techniques to all the Alexa developers, right? So that Alexa developers can start using CloudFormation and its platform and the feature that it provides to create and manage Alexa-related resources on the Alexa side. It's not on the AWS side. Along with this, now, once you have CloudFormation, and let's say you're an Alexa developer and you have CloudFormation and all Alexa-related skills or resource type natively supported, you can start actually accessing other AWS services using CloudFormation to kind of supplement or kind of complement your Alexa solution. So that's our vision, that we want to enable Alexa community, Alexa developer community, to start using infrastructure as code to manage their resources on the Alexa side, as well as use the same tooling to consume or access AWS resources. Iterating on Alexa skill is as simple as modifying CloudFormation templates and updating the stack. So it's a pretty seamless experience. If you haven't already, please do check out. And even if you are not an Alexa developer, I would encourage you to just hack out a new Alexa skill, maybe for your kid or for a friend. All right, I just want to share a sample template using this new Alexa skill. So here you can see there are 4 resource types in this particular template. Interesting thing to notice is that there are 3 resource types that are AWS types, and the 4th one is Alexa type. So the idea is to start bringing together all the some other non-AWS resource type and start putting together or start collaborating with other native AWS types to bring together one solution or kind of complement or supplement solutions for the Alexa. So it's a very powerful integration for us, and we believe that we will keep iterating on that and help Alexa developer community to start using CloudFormation and make it easier for them to not just provision or operate Alexa skills, but start using other AWS services to supplement or complement their Alexa solutions. All right, the next topic, it's very interesting for me, managing enterprise complexity. A lot of AWS customers are enterprise customers using CloudFormation at scale for several years. Based on their feedback, it gets challenging to manage drift at scale if you have like several teams, new team member joining, and let's say they don't know the best practices, they don't know the ground rules, they might go out of band, tinker with your stack resources, and CloudFormation is unaware of all those changes. So when you come back to CloudFormation and try to update the stack, delete the stack, funny things might happen, right? So let's address the drift detection piece. The second one, if you are in a regulated industry or if you have a business requirement to access AWS services within the AWS network without having to reach to internet and back. So what are your options? So I'm going to talk a little bit about our VPC private link support in CloudFormation. AWS account is an administrative boundary. We all know this. It's fast emerging as an infrastructure boundary also, such as VPC and subnet. So what are your options there? Like if you want to treat account as infrastructure boundary, how you want to seamlessly provision resources across multiple accounts, across multiple regions. So StackSets is a feature that helps you do that. I'm going to talk about StackSets and some of the enhancements that we have done on the StackSets side. And the last one is handling secrets in CloudFormation. Super important topic for us. Luis will be talking a little bit more on this topic, like how we can manage secrets, inject secrets in CloudFormation and propagate to other downstream services. Drift detection. It took, we announced it at last reInvent, I remember. It took a bit for us to release this feature. And the reason was that we were doing huge private beta for this, and we kept receiving a lot of feedback from customers. So this feature got released a couple of weeks ago. I would say it's like phase 1. We are still iterating on the feature. Again, drift detection allows you to detect if configuration changes were made to your stack resources outside of AWS CloudFormation. So what does it mean that now anybody tinkering with your stack resources directly via console or API calls, you can use this feature to detect those deltas. One of the feedback that we have got from customer about the diff viewer of this drift detection feature on the console, they are saying that this is a super powerful feature. It actually helps you pinpoint the exact drift, the exact changes, and using this information, they are able to take action. They are able to craft remediation, or they are able to figure out the next step. So do check out and help us provide or help us improve this diff viewer if you want to by using the feedback link on the console, and send us your feedback around diff viewer. A little bit more information on drift detection. Of course, we have dedicated APIs. If you're not using console in your environment, you have drift detection related APIs that you can use to automate your in your workflow, to automate things in your workflow or inject drift detection in your workflow. Today, we support around 51 resource types. Eventually, we have planned to support all the resource type in CloudFormation for drift. So stay tuned on that one. We'll be iterating at a higher pace for drift detection to include all the resource types. So today, drift is something like you have to actually, let's say, push a button to detect drift. So a lot of customers said that, hey, is there a way to actually get automatic alerts? So we released one config rule. It's a managed rule that you can actually use to get automatic alerts for your stacks if the stack has drifted or not. So based on the rule, right, config rule, whether it's compliant or non-compliant. So non-compliant on the config rule side means that stack has drifted. Customers have been asking, like, yes, drift detection is good. What about remediation, right? So the way our mental model for this feature is that we think in terms of two phases. The first one is about visibility. We want to make sure that you all have the right visibility before taking any action. So it's super important for us to kind of iterate on this feature and make sure that you have that crisp visibility into drift before you start thinking about remediation. So we want to, we'll iterate on the detection piece, and we'll make sure that we are at a point where you are actually confident about, yes, this is the information, and based on this information, I can craft my remediation. On the CloudFormation side, it's on our radar to actually provide managed feature related to remediation. So, but it's a little bit down on our roadmap. However, at this point, you can, based on the drift detection information, you can craft your own remediation. You can, again, go out of band and then change the configuration value to sync up with the template, or you can update the template to change the configuration values. Looking ahead, as I said, remediation is definitely on our radar, adding support for other resource types at a faster clip. And please keep providing feedback on this feature. We want to iterate really fast. Best way to do is use the feedback button on the console. I was saying that you might have requirements where you don't want to actually access internet when you are thinking of consuming AWS service. It may be you're working in a regulated environment, or you have a business requirement, right? So AWS Private Link actually allows you to access AWS services without hitting internet or without connecting to internet. So you can keep all your traffic within AWS network. So CloudFormation is now supported by Private Link, or let's say CloudFormation is integrated with Private Link. You can create VPC endpoint for CloudFormation service and actually access without going to internet and back. So this means no proxies, NATs, internet gateways, etc. This, for most of you, working in the regulated industries, this will actually help you improve your security posture. So if you haven't already, do check out this feature and see how it helps in your use cases. I was saying stack sets is a feature that allows you to provision resources across account, across region. And accounts, AWS accounts are becoming infrastructure boundaries now, apart from being administrative boundaries. So what we have done is, like, a lot of feedback coming on this side, stack set sites, and we are iterating on this feature at a faster clip, if you will. So the first thing I want to talk about is ability to customize your execution role and administrator roles. Earlier, when we released this feature, it was all canned, very, very static. The roles were very static, and customers were like, hey, we need more granularity. We need more flexibility in defining which sets of users are going to operate on which APIs, or which sets of users are going to provision which type of resources. So now you can actually customize your administrator role or execution role. The second piece is there's a feature called override parameters we released a couple of months ago. So in Stacksets, what happens, let's say you have a master set. That master set actually provisions, let's say, 10 different stack instances in 10 different accounts. So when you come back and you want to, let's say, update only 3 stack instances and do not touch the other 7 stack instances, what are your options, right? So using the override parameter feature, you can actually just update those 3 instances and not touch the 7th one. So this is giving a lot of flexibility to customers to decide or basically propagate changes to only a limited set of stacks. Limits, heard a lot of customers are talking about Stacksets limits. If you run into limits related issue, please reach out to us. We are actually extending limits on case-to-case basis, so happy to talk to us if you have any limit related issues on the Stacksets side. Our plans for future, we want to be in a place where limits is not a concern for you for Stacksets. So we are iterating on our side to make sure that you don't have to reach out to us for limits or limits increase. I wanted to actually provide you a small case study to showcase like how enterprise customers are using Stacksets to actually manage infrastructure at scale in an agile manner. And the best case study I could find in a short period of time when I was preparing for this presentation is a case on the Amazon.com side. So I'm going to invite, at this point, Manu, really young, gutsy, brilliant engineer on the Amazon.com side, and he's going to talk about how he and his team actually are using StackSets to manage infrastructure in a very agile manner at scale, at the scale of Amazon.com. Manu.
Hello, everyone. So I'm guessing many of you here are curious to know how Amazon.com leverages AWS StackSets. Well, one major use case of AWS CloudFormation StackSets in Amazon.com is in the provisioning of accounts. Amazon.com vents temporary AWS accounts to developers who are looking to build prototypes of their ideas in AWS. Temporary AWS accounts are just like regular AWS accounts, with the added feature that the accounts are automatically closed after a predefined duration of time. At Amazon.com, the accounts are automatically configured to close after 7 days. Temporary AWS accounts provide developers with an isolated and secure environment for them to work on their prototypes. Now, we don't want our developers spinning up EC2 instances or creating S3 buckets for their prototypes in the same accounts that support the production resources now, do we? As an organization, we also have certain security and compliance requirements that these temporary AWS accounts are required to meet. To meet these requirements, certain AWS resources, such as IAM roles and CloudTrail, have to be configured in the account before it is vended to a developer. I'll talk more about all the resources that need to be provisioned in a later slide. We leverage AWS CloudFormation to provision these resources during the account creation process. One of the main benefits of AWS CloudFormation StackSets that led us to consider using it is the ability to rapidly propagate cross-account changes with less code. When operating at the scale that Amazon.com does, we have thousands of developers who are looking to build prototypes of their ideas in an isolated and secure environment. I'll show you some numbers that exemplify the scale that Amazon.com operates in. On an average day, we see around 100 temporary AWS accounts created across the company. We've also had days where that number is significantly higher. For example, sometime earlier this year, we had 375 temporary AWS accounts created in a single day to facilitate a workshop. I'd also like to mention that at any given time, we have around 2,000 temporary AWS accounts that are open and active. When operating at this scale, it would be impossible for us to hand manage these accounts without pulling our hairs out. For example, when AWS launches a new feature, and if Amazon.com wants to enable that feature on all temporary AWS accounts, we need a way to rapidly configure that resource on all existing accounts and newly created accounts. AWS CloudFormation StackSets allows us to rapidly configure that resources across thousands of accounts within a matter of hours. Going back to temporary AWS accounts, we also have certain guardrails in place to prevent misuse of these accounts. Every temporary AWS account that is created has an AWS budget configured of $1,000. We get a notification from AWS budgets once that expenditure in the account is exceeded. Upon receiving this notification, we automatically close that account on behalf of the developer to prevent further spend. We also enforce that every developer only has 2 temporary AWS accounts that are open and active at any given time. These measures help to prevent misuse of temporary AWS accounts. Here we go. OK, so now that we have seen the scale of usage of temporary AWS accounts at Amazon, how do we ensure that developers have a secure and reliable way to work on their prototypes? Imagine one day you wake up and you have a brilliant idea for a feature that will save your company millions of dollars. You can't wait to open your laptop, sign into your AWS account, and start building a prototype. Now, what would your requirements for such an environment be? For starters, we definitely do not want our prototypes incurring exorbitant bills. It would be ironic if the feature, which was meant to save your company money, ended up costing you thousands of dollars to develop a prototype for. OK. And the second requirement would be isolation of resources. We do not want resources for our prototypes to be in the same accounts that support our production resources, as this poses an availability and a security risk. We also do not want another developer's resources for their prototypes to be in the same account as your own. This is why we vend completely independent and isolated accounts to every developer. And finally, we also want a way to automatically clean up the resources once we're done testing the feasibility of our prototypes so that these resources don't continue incurring spend. Now that we have seen why temporary AWS accounts are a great feature to have for developers, how do we prevent misuse of temporary AWS accounts? We definitely do not want our developers mining Bitcoins or setting up botnets on these accounts, as we want to enforce that these accounts are just meant for prototyping or to facilitate workshops and experimenting. So to prevent this, we enforce that every temporary AWS account meets certain security and compliance standards. To meet these security and compliance standards, we enforce that certain AWS resources get created in the account before it is vended to the developer. We enable AWS CloudTrail and configure it to send logs to a centrally managed S3 bucket in the log archive account. We enable cross-account access by creating IAM roles. Cross-account access is used to configure audit and emergency security administrative access to the incident response team. And as I mentioned previously, we also configure an AWS budget in the account during the account creation process to notify us if the expenditure in the account exceeds $1,000. We leverage AWS budgets to create this budget notification for us. And finally, we create an SNS topic as the notification endpoint from AWS budgets. These SNS topics will be listening to notifications from AWS budgets. And once we get that notification, we automatically close that account on behalf of the developer. Grab some water real quick. So previously, before using AWS CloudFormation stack sets, we modeled our account creation process as a sequence of steps in a workflow. Each step in the workflow was configured to basically create a single AWS resource. Here, we have a simplified subsection of our actual account creation graph. We have steps in there to create the cross-account administrator role, to enable AWS CloudTrail, and to create AWS budgets. Keeping in mind that this is just a simplified subsection of our account creation graph. Our actual production account creation graph has 9 separate steps in it to configure the required AWS resources. We start off the workflow by creating a cross-account administrator role, which trusts our administrator account. To provision any of the required resources, we assume this cross-account administrator role and then synchronously call the relevant AWS SDK APIs to provision that resource. Modeling our account creation process as a sequence of steps in a workflow resulted in a high operational overhead for the team. We had to implement error handling and retry logic for every step in the workflow. When a step in the workflow to provision a required AWS resource errored out, we had to spend time performing diagnostics to understand why that resource failed to get provisioned, and then manually rerun that workflow. When we have hundreds of accounts being created daily and having even a small percentage of those accounts fail to be created, results in a high operational overhead for the team, as we have to consistently spend time understanding why a certain account failed to get provisioned. And we also had to implement error monitoring and alarming on every step in the workflow so that the team would be alerted if any of the steps to provision the required AWS resource failed to get created. But that's not all. The biggest pain point that we faced was the work involved in having to update the configuration of any of the required resource. For example, we recently launched the feature to enable AWS budgets in accounts. To launch this feature, we had to write hundreds of lines of Java code, which I'll show you in a later slide, spend time updating the account creation graph, and then testing the updated account creation graph to ensure that the budgets gets created correctly as expected. This took us around a week to launch this feature. But after leveraging AWS CloudFormation stack sets, we were able to release such updates within a matter of hours. And CloudFormation stack sets also took care of the operational overhead for us. An important point to note is that policy requirements for temporary AWS accounts are always changing. When AWS launches a new feature, and if Amazon.com deems that that feature improves the security posture of temporary AWS accounts, we can decide to enable it on all existing accounts. And AWS CloudFormation stack sets allows us to propagate that resource update across all existing accounts within a matter of hours. And then at the start of the year, we came across this magical AWS service known as AWS CloudFormation stack sets. After reading that it would allow us to model our AWS resources in code while empowering us to update resources across thousands of accounts with just a single operation, we were hoping that it would be the silver bullet that would solve all our problems. And true enough, it did. We modeled all the required AWS resources in a CloudFormation template and created a stack set in the administrator account. Every new temporary AWS account that got created was added to this stack set, and we replaced 9 steps in the account creation graph with just a single step to call the API to create the CloudFormation stack instance. This greatly simplified our account creation process. But on top of simplifying our account creation process, leveraging AWS CloudFormation also provided us with numerous benefits. CloudFormation stack sets provided us with monitoring and alarming out of the box, so the team could sleep soundly at night, knowing that CloudFormation stack sets would alert us if a certain resource failed to get provisioned. Stack sets also gave us detailed error messages, so the times we had to spend in performing diagnostics as to why a certain resource failed to get provisioned was significantly reduced. On top of that, the biggest benefit that our team experienced after using AWS CloudFormation was that we were able to release updates across thousands of accounts within a matter of hours. If you wanted to update the configuration of any of the required resource, like basically create an extra IAM role or enable CloudTrail, all we had to do was update the CloudFormation template, and StackSet would take care of propagating that change across all the accounts in the StackSet. We did not have to write hundreds of lines of code, spend time updating the account creation graph, and testing it. StackSet also made it a breeze by providing monitoring and alarming, and taking care of the operational overhead for the team so the team could spend more time building features which brought value to customers. Now I'll show you example code to show you this is basically the code that we use to configure AWS budgets in the account. The purpose of this code is to give you an idea of how much code we had to write before we used AWS CloudFormation and how little code we had to write after using it. Here's the class that configures budgets in every temporary account. This class has around 300 lines of code in it, not including the code that we had to write for unit tests and integration tests. And so here, this method, createBudget, basically gets a configured budgets client and calls the relevant budgets API to configure the budget on the account. An important point to note here is that there's a lot of underlying code to basically configure the AWS budgets client by assuming the IAM role in the account. And also, there's a lot of code that's needed to be written to encapsulate the budgets request. I'll show you all the code for the entire class in the upcoming slides. And here we have the method to configure to encapsulate the budget request. Basically, this create budget request encapsulates the dollar value of the budget, how long that budget is going to be valid for, and the notification endpoint. And here we have code to configure the SNS topic as the notification endpoint for our AWS budgets. This is a topic that will be listening for events that are being emitted by AWS budgets. And finally, this is the code that we have to configure the budgets client. We assume the cross-account administrator role on the account and then use those credentials to configure the client. Those are the credentials which are used to then call the relevant budgets API to create that budget. Now, that's a lot of code that needs to be maintained just for creating an AWS budgets. Imagine one day we woke up and we wanted to add a new notification endpoint for our AWS budget. A lot of this code would have to be replicated just to add a new notification endpoint. And what I'll show you on the next slide will show you how magical AWS CloudFormation actually is. Now, remember seeing all that code in the past 4 slides? Now take a look at this. This is the section in the CloudFormation template to configure the AWS budgets. It is 8 times shorter, and not to mention just how much more readable and maintainable that code is. If we wanted to add a new notification endpoint for the budgets, all we had to do was add in an additional line in the subscribers parameter of the template here, and we would get an additional notification endpoint for our AWS budgets. We were significantly able to reduce the code that we had to write in having to propagate configuration updates across accounts. StackSets also made it a breeze by allowing us to propagate these changes across all existing accounts, and considering the scale that we operate in, we were able to release such updates within a matter of hours. And in conclusion, leveraging AWS CloudFormation StackSets resulted in significant developer productivity gains for the team. If policy requirements change and we had to configure a new AWS resource, we were able to do so 3 times faster. This means that we had 3 times more time to work on features which brought value to customers instead of configuring AWS resources on accounts. And as I mentioned previously, the code that we had to write in having to configure an AWS resource was reduced by 8 times. And now I'll hand it over to Luis to talk about improved credential handling in AWS CloudFormation.
Thank you, sir. Anu. Yeah, give him a hand. A lot of good work there. Good morning. How many of you went to replay last night? How many of you saw Skrillex? How many of you are going to add a hearing aid in your Amazon wish list? All right, let's talk about handling of secrets. Before I start with that, one of the things that we'll see in this next couple of examples is about extracting your configuration details from your CloudFormation templates and YAML files and JSON files. This is a good best practice. It makes those files, those templates, a lot more reusable. There's many other techniques to reuse them, for example. I'll talk about that as we go through some of this code. But that should be a best practice that you should be implementing in CloudFormation now. Last year, we added support for parameter store, string, and string list parameters. This year, we extended that by adding parameter support, secure string, and secrets manager support. And I'll show you a couple of examples of that. One of the neat things that we added as well is dynamic references to quickly retrieve those pieces of information using parameter types. So let me show you what this looks like. Clicker, okay. All right, so this is a typical CloudFormation YAML template. We are declaring 2 parameters here in the template, actually 3. An instance type that we're picking up from systems manager parameter store to create our EC2 instance. And we're also picking up the latest AMI ID. Let me concentrate on this one for a second. The good folks at systems manager parameter store, they have these global variables where rather than you having to look for the latest and greatest AMI for Amazon Linux 2 or Windows Server and then have to change your template and so on and so forth, you can refer to that global parameter, in this case AWS service, Amazon Linux, etc. Once again, if you've never done this before, take a look at those global parameters. Once again, it makes your templates a lot more reusable. But let's go back to the first one. I'm essentially picking up my instance type from parameter store in clear text in this example. Now, when we did this last year, we would have you declare a parameter and then use that parameter on the template. One of the things that we're doing this year is that we're creating this thing called dynamic references, which now it's no longer necessary to declare the parameter on the template. So now that code turns into this code. Makes the amount of code that you have to write a lot less. So look at the last line. Curly brackets, resolve, then the service name, in this case, systems manager, and then your parameter and version. So now you have to write less code. Now you don't have to declare one parameter less. So now you kind of like save that from your parameter limits, and much more compact. So that's an example of using dynamic references with non-secure strings. Let me show you an example with secure strings. So this is a definition of an RDS database, in this case a MariaDB database. And if you are a long-time user of CloudFormation, you probably have kind of wondered, wow, I have to put my master user password. Well, that's a requirement for RDS, and it's, requirement. But unfortunately, having that password in your CloudFormation file, not necessarily the best idea in the world. Well, now with dynamic references, you can do something like this. So now you can use the curly brackets, and now we're saying it's SSM secure, and not have to include your changing secret in the template. Now, you have a couple of options to handle these secrets. Parameter store is at no additional cost to you, but and it does allow for things like versioning and everything. But if you have to include into this taking your secrets and rotating keys, etc., a better option might be Systems Manager. So here's the same example using Secrets Manager. And in that case, I'm not only including the password, but also the username. In our implementation of Secrets Manager, you can use any Secrets Manager parameter in any attribute in your template. So very flexible, and we're getting closer to having a more defensible best practice when we author templates. By the way, I usually don't sound like this, but like after 14 of these, I sound like somebody stepped on a Lego or something, and that's okay. All right, so let's talk about developer productivity. If you've seen some of my sessions this year and last year, that's kind of like one of my passions when it comes to CloudFormation and developer authoring. We're gonna talk about extending template functionality, faster code assistance, and higher level language modeling. Let's first talk about macros. Now, we released macros a few months back. How many of you have already used or tinkered with macros? Just a few of you. Okay. Hopefully, I'll give you enough information to entice you to actually take a look at it. So here's the idea behind macros. We want to enable developers to write shorthand abbreviated instructions that expand automatically when deployed. What that means is that now you can take standard CloudFormation YAML language and add utility functions such as iteration and looping, string manipulation, math functions, external commands, and other things. You can ensure also with the macro that a given resource is defined to comply with your standards. The way that we set up macros, they are a lot easier to share and reuse across stacks than previous mechanisms that we've had before. And I'll show you kind of like go through the process of setting up the macro. But once you write the macro and deploy the macro, within that account, in any stack, you can have anybody call that macro multiple times from all their stacks in their account. Let me kind of show you what this looks like. And I guess I don't expect somebody sitting over there to be able to read this, but all of you should be able to read it. All right, so in this case, I'm declaring the macro call as transform in the first line, and I'm declaring a bucket. Now, for most of you that are CloudFormation users are building templates, you know that one of the attributes of bucket is not count. Well, that count equals 3 is actually my call for the transform. When I save that, and if the transform is already deployed, this gets converted into 3 buckets. So with one line and with one relatively simple macro, now you have the ability to have a count type of iteration in CloudFormation. And not only do you have that ability, you get to decide how that count iteration works. Do you want to use just integers and numbers, or do you want to use labels to actually add the other resources? So a lot of flexibility there. This particular macro is available as an example on GitHub. And this particular piece of code was made generic enough that it works with any kind of resource. In this second example, we have an SQSQ, and we want a count of 2, and it creates 2 of those. So pretty handy, just very one simplistic example there. How much code did that require? That's it. And if you consider that you have to have the handler at the bottom, and the first call is process template, where we're pretty much allowing you to take the entire template and make as much logic transformations as possible. It's really about the middle half of that screen. This happens to be in Python, but because macros can be made with any Lambda language, you can use Python, Node, PowerShell, and if some of you have heard from this week, you can now do Lambda functions with Ruby as well. So, how do I go about and deploy the macro? I created my Lambda function, about a page worth of code. I throw at it a couple of events to test it. And then that's how much it takes to actually put that macro and make it available in your account and in your region. In this case, I'm using actually 2 transformations, not only the macro transformation and the SAM, or serverless application model transformation, and in just a few lines of code, you can deploy that macro. So this not only is valuable for CloudFormation users that know higher level language programming like Python, Node, and so on and so forth, but once these macros are deployed, you can make these available to other CloudFormation users, and they don't need to know how the macro works and still be able to use the macro in their templates. Let me show you a couple of other examples. In this template, I'm putting a default input string in a parameter. I'm saying this is a test input string, and then embedded inside of the definition of the resource, I am calling a macro here called string macro. And I'm passing parameters to the macro. So not only am I passing the entire template, I can also pass different types of parameters. In this case, the parameter is a parameter that is getting passed to our template. And I'm telling, take this little piece of text and apply an operation, in this case, upper. When this template gets transformed and translated, the resulting template, uppercase is the string. Now, let me show you another example. This is one that's kind of handy, because imagine if you had in your organization a required standard to say, every time you create resource X, you need to make sure that has a policy. You need to make sure that you configure it as we configure all our other resources. So here's some sample code that can help you do that. This macro's name is defaults. So in this case, every time an S3 bucket is created, I want to make sure that it has an access control property and a bucket policy. And I can generate additional resources that have nothing to do with that S3 bucket. And I can generate additional logic, including conditions, intrinsic functions, and more. I can even allow my macro, if it's fancy enough, to say, if you don't pass me any other parameters, do this. But if you pass me some override parameters, do something different. So by just adding that transform defaults, this code will say, for every S3 bucket that I find, I'm going to add access control, I'm going to add a bucket policy, and I'm going to create a policy document. Again, the user of the macro doesn't need to know or care that you might be the compliance infrastructure person that will make sure that every time a bucket is created, these other things happen. I'm using the example of a bucket because most people are familiar with S3, but you can do this with any of the 300 plus resources that we support. So this gets pretty powerful pretty quickly. So that's macros. I can tell you that when we released it earlier this year, we had a lot of good feedback, positive feedback from social media. Within hours of us releasing the macro feature, there was a second GitHub repo of macros made by the community. And we absolutely expect to see a lot more people contributing to these macros. So not only can you share them easily internally, So you could also share them easily publicly. One more thing about macros. As you probably know, especially experienced CloudFormation users, we've always had the ability to let you add custom code via custom resources. And in the session earlier this week, I got asked, well, is doing macros harder or easier than doing CloudFormation custom resources? In my opinion, it's easier, because when you create a CloudFormation custom resource, you have to tell us what do we do when we create that resource, or when we update it, or when we delete it, and handle that event. Here, you don't have to do that. So you can create macros that are a lot simpler. On the flip side of that, the fact that you can create simple macros does not keep you from creating very complex macros too. So I think it's worth looking at. Next thing that I'm really excited about is this CloudFormation linter. So let me tell you a little bit about how that came to be. So as we talk to customers, sometimes, in fact, I would argue too many times, they'll get frustrated with for us not having enough validation in advance for a template, and only finding out that you have a runtime error too late and have to go to a rollback and troubleshoot and go back and deploy. So improving the validation is something that can help any CloudFormation user. Well, we've tried to go further than that, not only improve it, but also make it easy for you to validate things at the time that you're authoring your template. And that's where this linter comes in. Now we'll have a linter that is super easy to integrate with IDEs via plugins. And I'll show you a couple here, but there's about 5 or 6 plugins integrations that are available already. This provides the quickest feedback on code errors, warnings. It obviously does syntactical evaluation of YAML and JSON, but it goes further than that. It checks for template limits. It checks for whether or not you have required parameters in place. It has a lot of checks out there. It is powered by a resource specification. How many of you are familiar with the CloudFormation resource spec? Handful. Fantastic. So not only does the linter use this, but also other third-party tools. The resource spec is a machine-readable file that essentially says every resource that's supported by CloudFormation and every attribute on that resource that's supported. So by leveraging that, and since the resource spec gets updated fairly frequently, the linter will always support the latest and greatest CloudFormation resources. There's something else that I want to say about the resource spec there. If you create a macro or a custom resource, we give you the ability on the linter to actually make your own custom rules, so that you can take our resources that we support and the resources that you create yourself and add those to the linter. So if you now become an expert on macros and custom resources in your company and have created a handful of them, you can actually override the resource spec and be able to actually lint and validate your own custom code. And a big reason for that is because the linter is one of a few open resource projects that we intend to release as time goes on. We've already released a couple, and we intend to release more. Obviously, the macro samples are also on GitHub. CloudFormation documentation also on GitHub as well this year. So we provide instructions to extend it and to validate with your own rules. Here's another important point. You can use this in headless mode in your pipelines. So if you're building a CloudFormation pipeline and you're building tests with tools like CFN NAC for security testing and everything, you can have a test that uses CFN lint, which is the name of this particular program, and actually be able to say, I'm going to kill my pipeline if after my lint test, I don't get a return code of 0. This is actually a screenshot of the linter in Visual Studio Code. Immediately after I load a file that's already been made, you can see like those yellow bubbles on the left side, essentially indicating something is amiss here. You can hover with your pointer and get the message there. Or we take advantage of the Problems tab and essentially say, for this particular macro, CFN-lint is reporting that there's an invalid type, for example. So what we're hoping that happens is that we improve the developer productivity by avoiding all of these validation cases that may cause a rollback, and know that you're doing the right things by the time you save the file in your editor. It's only been out there now for a few months, but it's iterating fairly quickly. Some of the recent features of the linter include processing multiple files, better handling of conditions, integration with SAM local, and service rules for Route 53 and code pipeline. That's where you can go get it. Plugins include for Visual Studio Code and Atom. There's also plugins for Vim and a handful of other editors. Its current release is 0.9, and since its inception, it's been downloaded already more than 55,000 times. Let's talk a little bit now about language, higher level language modeling. With YAML and JSON, you're primarily using declarative syntax. It provides a level of abstraction so you don't have to learn all the API and SDK commands. It's usually more approachable for CloudFormation users that don't have a development background or perhaps are more operations type of administrators, sometimes at the expense of not providing full language constructs like functions, although as you saw today, macros are closing the gap in some of those cases. However, there's a lot of options that exist if you want to use higher level language. There's opportunities for coders of JavaScript, TypeScript, Python, for example, Troposphere is one of my favorites there, Ruby, and others. So the higher level languages do give you more opportunities to componentize and abstract, so that in the higher level language, you can kind of like with one line, generate a whole bunch of resources at once. So declarative code, imperative code, the options for CloudFormation users in the terms of how they author templates are expanding significantly. And part of that is because CloudFormation has become a very important large service with hundreds of thousands of users. You can obviously do things without CloudFormation by using SDK and CLI. Those are all step-by-step imperative instructions, where doing things like error handling and state updates are up to you. Declarative, one example is CloudFormation, YAML language. Terraform's HCL language is also primarily declarative with some other functions in there. And some abstraction and logic flow is possible here. There's DSLs like Troposphere, Sparkle Formation, and Go that you can leverage the higher language constructs. And one of the biggest benefits of using one of these DSLs is that if you're already a Python developer and know how to do unit testing in Python, you can use unit testing on this code as well and still be able to generate CloudFormation specific code. And when you do generate that, you take advantage of rollbacks, stability, stabilization timeouts, etc. And then you have imperative options. And that's the one that I want to mention today, AWS SDK. You can use the full power of programming languages, some like the DSLs, but you can make more sophisticated abstractions, and you can reuse more sophisticated abstractions from other people. CDK works by essentially rolling up resources like constructs in your code, or giving you the ability to do that, compiling that down to CloudFormation, bundling and packaging everything, and then setting up your stacks for you. If you've never seen it, you can pretty much go to NPM, install it, initialize an application. It creates all the files for you, builds your files, and deploys them. And it does, behind the scenes, all the necessary packaging and deployment for CloudFormation. In fact, when you see it running, this might look familiar to you because they're CloudFormation events. Runs fairly quickly. Now let's change one file. And this is what will drive the point home on this amount of abstraction that you can do. I'm going to go in here into this TypeScript code and add code for a queue. So essentially a small line, only one line of code, save it, build it. And with just that snippet of code, if I do a diff now from the original file, I created an SNS description and a queue policy behind the scenes. So from a programmer's perspective, I'm getting the automation, I'm getting the ability to do unit testing, I'm getting that level of, it can generate things for me as well. I strongly suggest if you are a programmer that's not intimidated by higher level languages, to take a look at the CDK. Definitely take a look at the linter, and take a look at the macro samples that we have from AWS Labs and from other providers. You should expect more open source projects for us to be providing to you to improve developer experience, and in turn, we expect you to contribute to us. In fact, we just started a CloudFormation Slack channel some time ago, and in less than 5 months, we have over 500 collaborators. If you're interested in getting involved with that, you can send me or Anil a direct message via Twitter, and we'd be happy to send you an invite via email. And then you can join the community. There's a bunch of AWS people and people from the community, and in many cases, they help each other within minutes or hours. So you should expect more contributions from us, and we expect, as we're building this community, to get more contributions from macros, custom resources, utilities, samples, and many more things. So to summarize, we talked about new console, new resource support, modernizing CloudFormation, making CloudFormation more useful for enterprise cases, although drift detection, you could argue, is useful for everybody, VPC private link. In my mind, Stacksys enhancements, and probably there's so many Stacksys use cases that people have still failed to realize or haven't discovered yet. How to handle secure strings, and improving developer productivity with macros, the linter, CDK, and community. We went 2 minutes over, my apologies. We're gonna go outside and spend some time if you wanna ask us questions. But mostly, thank you so much for coming on Friday morning. We're very proud to have you as our customers, and make sure that you give us feedback on the mobile app. Thanks so much.